let's find the solution to this second order non-homogeneous recurrence relation. So using the method of superposition, the solution is a superposition of the homogeneous solution plus the particular solution. And for the homogeneous solution, we assume a solution of the form lambda to the n, which we substitute into the left-hand side of this recurrence relation. So we have lambda to the n minus 4 lambda to the n minus 1 plus 4 by lambda to the n minus 2. And that's equal to 0. And again we factor out lambda to the n minus 2. So we have lambda squared minus 4 lambda plus 4 is equal to 0. So for this equation to be satisfied, the characteristic equation must be equal to 0. And we can factorize it as lambda minus 2 squared. So therefore lambda is equal to 2. So this is a repeated real root. So therefore we can write a homogeneous solution as some constant a plus a constant b by n by lambda to the power of n. And for the particular solution, we can see that 2 to the power of n appears in the homogeneous solution. So we assume a solution that has the same form as this function, but we multiply the constant by n squared, and that's multiplied by 2 to the n. And now if we substitute this in the left-hand side of the recurrence relation, we get the left-hand side is Sn, which is Cn squared by 2 to the n, minus 4 by Sn minus 1, which is C by n minus 1 squared, by 2 to the n minus 1, and then plus 4 by Sn minus 2, which is C by n minus 2 squared, by 2 to the n minus 2. And now if we factor out 2 to the n minus 2, we get Cn squared by 2 squared minus 4c multiplied by 2 to the power of 1 by n minus 1 squared, and plus 4c by n minus 2 squared. And now we can expand the terms in the brackets. So we have 4c n squared, then minus 8c by n squared, and minus 8c by minus 2n is plus 16cn. And then minus 8c by 1 is minus 8c. And then we have 4cn squared minus 4n by 4c, which is minus 16cn, and plus 4 by 4 is 16c. And therefore we have 4cn squared minus 8cn squared plus 4cn squared all cancel, and 16cn minus 16cn cancels. So we're left with minus 8c plus 16c is 8c by 2 to the n minus 2. And we equate this with the right hand side, which is 3 by 2 to the n, which is the same thing as 3 by 2 squared by 2 to the n minus 2. So therefore we have 8c is equal to 3 by 2 squared, which implies c is 3 on 2. And that's our particular solution. So therefore our solution Sn is a superposition of the homogeneous solution, which is a plus bn by 2 to the n plus the particular solution, which is 3 on 2 n squared by 2 to the n. And now we can apply our initial condition S0. So that will be A plus B by 0 by 2 to the 0 is 1. And this term is 0. So therefore A is equal to 1. And if we apply our second initial condition, S1 is equal to 1, so that would give A plus B by 1 by 2 to the 1 plus 3 on 2 by 1 squared by 2 to the 1. So that gives 1 is 2A plus 2B plus 3. And if you substitute A equals 1, we get B is equal to minus 2. So therefore, our particular solution is 1 minus 2n by 2 to the n plus 3 on 2 by n squared by 2 to the n. Please subscribe, like and comment to help me reach more students.